Hi everyone, in this section we're going to look at solving quadratic systems. Remember, when you solve a system, you're looking for the points that they have in common, and we're going to deal with a quadratic or a parabola and a line, and also even a parabola and a parabola. So when we're solving these, it could be that we have no solution at all. Let me show you what I mean. It is possible to have a line and a parabola and they never intersect, and you could have no solutions. Or you could have one solution where the two just intersect at one point, or you could have two solutions where they intersect at 2 points. This is true even with a quadratic and a quadratic. It's still the same idea. So let's look at how to put them together in order to solve. And one, I just gave you a hint on the board. One is to actually graph them. Here's an example of a problem you could get where they ask you to solve by graphing. It is not the easiest way to do it. Even if you do it on a graphing calculator, then you have to work to manipulate to find where the points of interception are. And so it can be kind of tedious. Also in a graph, you can't tell, is this exact or not, unless you're perfect at drawing. However, when you get on the computers, and they say solve by graphing, you're going to have to graph these things. So remember how to graph. Remember negative b over 2a will give you your axis of symmetry. In standard form like this, that'll give you your y-intercept. That's what you need to know. That will help a lot. So in other words, negative b over 2a, which would be negative 5 over negative 2, or 5 over 2. So our x-axis is at 2.5, and plug that in to find the y of your vertex, and then 0, 6 is a point, and you'll be able to graph the quadratic, and this one would move down. Then when you graph this line, remember this is the y-intercept, your slope is 1. So 6 on the y-axis, 1 over 1, just diagonals, and then look to see where they intersect. So I'm not going to take the time to graph all that. I'm just going to remind you that that's one method. I'm going to show you how to do it using arithmetic, which is really a lot simpler. It's just I wanted to remind you of those steps in graphing. Y-intercept, negative b over 2a, and you're good to go for using it on the computer when they want you to graph. Okay, I'm going to show you how to solve this using substitution. So we are going to put them together. We're going to substitute one inside of another. For instance, we know in this equation, this quadratic and y are equal to the same thing. And in this line, x plus 3 is the exact same as y. So I am going to put these equations together by substituting in place of this y, I'm going to put x plus 3. That's how I'm going to put them together. It'll look like this. There we go. Now I'm going to set it equal to 0, and I'm going to do it in a way that'll give me a positive x squared. So I'm going to move this over here, make it positive x squared, and I'm going to add this x over here plus 2x, and I'm going to take away this 6 minus 3 equals 0. Now I've set it equal to 0, and always before I whip out my quadratic formula, can I factor this? Are there two factors of negative 3 that add up to 2? And there are. This factors to be x plus 3 times x minus 1. 3 minus 1 is 2, and multiplied, negative 3, it works. So those are my factors. So what are my solutions? This one is negative 3, this one is 1. Now remember, I am looking for the points where these two figures intersect. I know my two x's. My answers are going to be ordered pairs. My x's are at negative 3. One of my solutions has an x of negative 3. The other solution has an x of 1. All I have to do is figure out the y of my ordered pair. So I can plug these into either one of these, and boy, wouldn't that be simpler. So let's plug them in here. If x is negative 3, negative 3 plus 3 is 0, so that makes negative 3, 0, one of my solutions. If x is 1, then 1 plus 3 is 4, so when x was 1, y was 4, and that's my other solution, and there are my two solutions. How do I check? Plug them into both. I already know that they work in this one. If I plug them into here, when I make my x -3, will I get 0 for my y? And when I make x 1, will I get 4 for my y? Be careful when you make x -3. Watch this negative. So this x squared, even though I'm squaring a negative, it's still going to be negative because of that negative out in front of it. All right, so be careful when you check that. Let's practice one more just to feel really good about it. I have this quadratic and this line. I want to know their points of intersection, so I'm going to substitute in place of this y, I'm going to put x plus 5. Now I'm going to set it equal to 0, and I'm going to do it in such a way that leaves my x squared positive. Now I'm going to look to see if I can factor. If I can't, I'll use the quadratic formula, but there are two numbers that multiply to be -5 and add up to be +4, and that would be 5 and -1. So this factors to be x plus 5, x minus 1. So now that means my solutions are -5 and +1. So one at a time, plug those in. Do this one because it's easier. When x is -5, oh look, this looks just like the last one, doesn't it? When x is -5, y is 0, so that's my first ordered pair. And when x is 1, y is 6, so that's my next ordered pair. And there we go, there's my two solutions. Here's another system of equations, only this time we have two quadratics. Not a quadratic and a line, but they're both set equal to y, so we can still substitute one for y, and then it'll look like this. There we go. So in place of this y, I put this, and I got that. So now what I want to do is set this equal to 0. So I'll go ahead and move this over and all of these over so that it equals 0. This becomes 2x squared. This becomes 8x, and then the 12s cancel out, and there we go. Now what do I do with this? Look and see, in this case, both of these can be factored by 2 and x. So I'm going to factor out the 2x. And I'm left with x plus 4. So 2x times x plus 4. So what are my two zeros? This one is 0, and this one is -4. Now I plug these in one at a time into either equation. I'll go ahead and do this one. If I make x 0, that's easy. If x is 0, y is 12. There's one of my solutions. If x is -4, -4 squared is 16. 16, this is -28 plus 12. Oh, well, that's 0. So if x is -4, y is 0, and there are my two solutions. And that's how you do it with using substitution. It's overall not bad, but notice all the math. Is it easy to make a mistake? So take your time, be careful. Okay, the last type of problem you're going to have in this section is trickier. I apologize for that. And that's when you have a system of inequalities. When you have a system of inequalities, you have to graph. There's no getting around it. And the reason is because the solutions are regions in the graph that have to be shaded. So you have to graph each and every one and then shade it appropriately. So let's look at this first one right here. We have -b over 2a, which is 9, positive 9 over -2. So our x will be -4.5. And so I plug in -4.5 to these to see what my y of my vertex is. So my x of my vertex is negative 4.5. When I plugged that in, negative that squared, it was negative 20.25. And negative 9 times negative 4.5 was positive 40.5 minus 2. And when I simplified all that, I got 18.25. So that means my vertex is at negative 4.5, which I have this in the wrong spot. I have it 5.5. Negative 4.5, 18.25. There's my dot in the middle of my 2. Now notice negative 2 is my y-intercept. Nice. So since I numbered this by 2, there's my y-intercept, and my line is dashed. So I'm going to go on either side, right? Here, and there we go. There's my somewhat sloppy, but you get the idea, of my parabola. Where does my shading go? My y's are less than that, so my shading will be in here. Okay, now I need to do this one. So this is, or they're just regular y equals x squared, but it's lowered down 2. So here's my vertex of this one. And so when I go, and it's also dashed, and it's greater than, so my shading is inside or above here. So the area that they have in common is actually this. What's inside of this and inside of that is this strip. You guys, it's just complicated. You have to take your time, graph carefully, and do the best that you can. But that's how you graph a system of inequalities. So I've introduced this to you in a very short amount of time, really, not much practice, how to solve by graphing, but really how to solve with substitution, and then using algebra in order to do that. And then inequalities, carefully graphing either the lines or the parabola, and where does the shading go? What do they have in common? That's the part to shade. This is the most, just historically teaching, this tends to be the most difficult for students. So I would really encourage you to take your time and be careful with it. That's it, without a lot of extra practice. That's the basics. If you need any help, let me know. That's what I'm here for. All right, so that's this section. Bye for now.